Alright folks, welcome back. In this video we're going to discuss yet another example of solving systems of equations using elimination. Right? This elimination process that we have here is a great tool for us to solve a system of equations for its solution, which is the x and y value which satisfies both equations in the system. Let's take a look at the system now. Here we have 4x minus y is equal to 12 and 2x minus y is equal to 0. Those are our two systems, or our two equations in the system. We want to solve this with elimination. Now remember, elimination is this process in which we combine the equations together, combine like terms in both equations, and in the hopes of trying to eliminate one of the variables. Now here, if we try to add these together as they are, what happens? Well, 4x plus 2x makes 6x, negative y minus y makes negative 2y, that's equal to 12. Now see, this is no good because now I have one equation and nothing else to show for it, right? I don't have one of the variables by itself. The goal of elimination is to eliminate one of the variables. Here I didn't do that. Why did that not happen here? Well, that's because, remember, for elimination we need one of the variables to have the same coefficient, just one is positive and one is negative. Here I don't have that. I don't have that at all. I have a 4 and a 2. They don't cancel out. I have a negative y and a negative y, or a negative 1 and a negative 1. Those don't cancel out either. So I need to change one of these equations so that way it does have a coefficient that will cancel out. The easiest way to do that would be to look at these y's in this particular equation, because notice, they have the same coefficient. They're both negative 1s. I just need one of them to be positive. So how can I make one of them positive? I can multiply both sides of the equation by negative 1. So I'm going to multiply this second equation by negative 1. Negative 1 times 2x gives me negative 2x. Negative 1 times negative y gives me positive y, which is good now because I have a negative y and a positive y. They should cancel out. And then negative 1 times 0 is still 0. So I just changed all the signs by multiplying everything by negative 1. Alright, so now we have two new equations, or one equation that's still the same, and then the new one which we just changed the signs on. So let's rewrite this. 4x minus y is equal to 12, and then we had negative 2x plus y is equal to 0. That's what we had after we multiplied both sides by negative 1. Now that we've changed the signs, when I combine these equations together, what do I have? 4x minus 2x is 2x. Negative y plus y, there's that cancellation, 0. That's equal to 12 minus 0, or 12 plus 0, which is 12. Now, nice and pretty, I have 2x is equal to 12. I can divide both sides by 2, and I'm left with x is equal to 6. That's great, because now that I have x is equal to 6, I can plug that in to either equation and solve for y. So let's use 4x minus y is equal to 12. 4 times 6 minus y is equal to 12. Well, that's 24, right? 4 times 6 is 24. So let's have that there as 24 minus y is equal to 12. We subtract 24 from both sides. We get negative y is equal to negative 12. And by switching the signs, we get y is equal to 12. So I have an x value, I have a y value, so my solution is 6, 12. And we were able to arrive at that using elimination. Now remember, elimination, that process, requires that one of the terms will cancel out when we combine the equations together. And we were able to force that by multiplying both sides of the equation by negative 1. And then we were able to combine them together, and the negative y and the positive y eliminated, and we were left with one variable, and we could solve. So this is elimination, guys. Check back in for more examples. I'll see you next time.